All right, in ALEKS, you're going to be asked to graph rational functions with holes. You're going to be given a function that looks something like this. This is f of x equals 3x squared minus 12x over x squared minus 5x plus 4. The first thing you're going to do is you're going to factor your function. You're going to find the asymptotes in the holes. Then you're going to simplify and graph. Okay? So we can common factor for the top part here. Get 3, we can take a 3 and an x out of both of these, and that leaves you with x minus 4. And the bottom part, we can factor that to, that's going to be x minus 1 and x minus 4. Now we can see that we have two values in the denominator. Now remember, you cannot divide by 0, so anything that makes the denominator 0 is either an asymptote or a whole. Okay, so this right here, this one that's going to cancel out, that is going to be where the whole is. So if you take x minus 4, set it equal to 0, and solve it, you get x equals 4. Okay, so we don't want to forget about that. Okay, that's where the whole is. And then this other one here is going to be the asymptote. So x minus 1 equals 0, so x equals 1. Okay. Then we also want to look at our function, and we see that the highest exponential power in the numerator and the denominator are the same. And if that's the case, we take the values, the coefficients in front of them, and I just put a 1 there because if it's just an x squared, then there's a 1 coefficient. So this is 3 over 1, and we simplify that to 3, and that is our other asymptote, y equals 3. So we have a vertical asymptote and a horizontal asymptote. So basically what we can do is we can graph those. That's the first thing that we do in ALEKS. To graph those, you click on this rational function with horizontal asymptotes. Click on that button and you place a point, so x equals 1. We just click there, and then we can move this around to place the horizontal asymptote, and that's y equals 3. Click on that. Then it's asking you to place these points. Okay, so in order to place these points, we need some values. So what I suggest you do is you pick a value to the left of your vertical asymptote. So I'm going to pick 0, and I'm going to pick a value to the right, and I'm going to pick 2. So I'm going to basically find out what happens when x equals 0. I plug that into my function. So f of 0 equals 3 times 0 squared minus 12 times 0. Now I'm writing this all out, but you're going to figure this out, right? 0 squared minus 5 times 0 plus 4. So when I go to simplify this is going to end up giving me 0 over 4, which is 0. So I have a point when x is 0, my y is 0. Okay, so that's one point, and then we were going to test another point, x equals 2. So we plug that in, f of 2 equals 3 times 2 squared minus, and I really probably should have just plugged it into the simplified version, I'm sorry. So you can see if I simplify this, the x minus 4 over x minus 4 simplifies, and that gives me 3x over x minus 1. So if I'm plugging that in, I get 3 times 2 over 2 minus 1. A little less calculations to do, and I could have done that for this one too as well. I should have. So I apologize for doing that the hard way. Okay, but it still works. So 3 times 2 is 6, and 2 minus 1 is 1. 6 over 1 is 6. So when I input a 2, I get a 6 as my output. So I'm going to plot these points 0, 0, and 2, 6. So I come back over here, and I have 0, 0. I place a point there, and 2, 6. I place a point. Oops. That was not. I'm going to click undo. I want that. Oops, it's going to make me redo the whole thing again. Okay. So let's see. At 1, and y equals 3, and 0, 0, and 2, 6. Okay. Now, the very last thing you don't want to forget is where that hole was at x equals 4. So I go 4, go up. Well, I better click this button 4. So 4 up until I hit the graph. And I click and put that hole there. And that is how you do this question. How you graph a rational function that has a hole. Here's another example. So if I have g of x equals a negative 3x minus 12 or over x squared plus 5x plus 4, we factor that, and you can see I can common factor out a negative 3, and that's going to leave me with x plus 4, and I'm going to common down here. I can just factor this into x plus 1 and x plus 4. Okay, so I'm going to rewrite this now so that I don't forget that g of x equals a negative 3 over x plus 1. Right, there's my simplified version, and I can see that this one here, remember that this is going to be the asymptote, so x plus 1 equals 0 gives me x equals a negative 1, and here this is going to be x equals a negative 4. This one's going to be the whole. Okay, and then we need to consider for our horizontal asymptote, and we see here that the highest power of the numerator and the highest power of the denominator, these are not the same powers. When that happens, then y equals 0 is your other asymptote. Okay, so I've got to consider these things for my asymptotes. And then, so I want to consider a point on the left of my x equals a negative 1, so when x is a negative 2. So let's say g of negative 2, we want to calculate what that's going to be. And so it's going to be a negative 3 over a negative 2 plus 1. So a negative 3 over a negative 1 is a positive 3. So that gives me the point when x is a negative 2, my output is a 3. And then I want to consider another point to the right of that. So to the right of a negative 1, think of the number line, is 0. So I'm going to do g of 0. And I'm going to plug 0 in for x. And that gives me a negative 3 over 1, which is a negative 3. So there's my other value. When x is 0, y is a negative 3. So I'm going to plot these asymptotes. I'm going to then plot these 2 points, and then I'm going to plot this, mark the hole on the graph. Okay, so let's go over here. We're going to click on the rational function so we can do our asymptotes. So x equals a negative 1, and y was 0, so that's along the x-axis. And then I need to place a point at, let's see, 0, negative 3. There's one point, and the other point was at negative 2, positive 3. Okay, and then I have the hole at x equals a -4. So click the button, go to a -4, go up until you hit the graph, click that point, and there we go.